Good morning. I'm Ms. Grew with the Gulfport School District. Today we are going to be talking about equivalent fractions. Our I can statement for this lesson is I can explain why a fraction AB is equivalent to a fraction n times A over n times B by using visual fraction models with attention to how the number and size of the different parts differ even though the two fractions themselves are the same size. Some important vocabulary to talk about before we start today's lesson: denominator. It's the number below the line in a fraction that tells the number of equal parts in the whole. Equivalent fractions. They're two or more different fractions that name the same part of a whole or the same point on a number line. A fraction is a number that names equal parts of a whole. A fraction names a point on the number line. The numerator, the number above the line in a fraction that tells the number of equal parts that are being described. Unit fraction, a fraction with a numerator of 1. Other fractions are built from unit fractions. For our first practice problem, it's to find a fraction equivalent to 5/6 using multiplication. So we're going to write our starting fraction down. And then whenever we go to find an equivalent fraction, we're going to pick a friendly number to multiply the numerator and the denominator by. So we're going to start off with a pretty simple one. We're going to pick 2. So if I multiply my numerator by 2, I also have to multiply my denominator by 2. 5 times 2 is 10. 6 times 2 is 12. So our equivalent fraction is 10/12. We could do this again with another number. Say we chose 5. We could multiply our numerator by 5. Whatever I do to my numerator, I also have to do to my denominator. 5 times 5 is 25. And 6 times 5 is 30. Okay, so our next problem has the equivalent fractions written out, but we are trying to solve what we multiplied by. So what did they do to 3 to get it to 6? They multiplied by 2. I know whatever I do to my denominator, I also have to do to my numerator. And 1 times 2 is 2, so we know we got the right answer. Write the missing numbers to show a different equivalent fraction for 1/3. Okay, this one's a little bit different. They gave us 1/3. We don't know what the equivalent fraction is, but we do know that they multiplied our numerator by 4. And just like in the previous problems, whatever we did to our denominator, we also have to do our numerator. The same thing works backwards. So whatever we do to our numerator, we also have to do to our denominator. So I multiplied by 4 on the top, which means I'm going to multiply by 4 on the bottom. So we're multiplying our denominator by 4 as well. 3 times 4 is 12. And 1 times 4 is 4. So 4/12 is our new equivalent fraction. All right, write the missing numbers to show a different equivalent fraction for half. Okay, so here they gave us the fraction half, and it's going ahead and telling us that we have to multiply by 4. So just like in our previous problem, whatever I do to my numerator, I also have to do to my denominator. 1 times 4 is 4, and 2 times 4 is 8. So 4/8 is equivalent to half. Okay, our next problem is 5/6. Now they have actually worked out the new equivalent numerator for us. They said 5 times 2 is 10. Whatever I do to my numerator, I also have to do to my denominator. So I'm going to do 6 times 2, and 6 times 2 is 12. So 5/6 is equivalent to 10/12.
Wow, y'all did an awesome job with equivalent fractions. Let's talk about our I can statement for our lesson today. Today, we explained why a fraction AB is equivalent to a fraction n times A over n times B by using visual fraction models, with attention to how the number and size of the parts differ, even though the two fractions themselves are the same size. Great job today, guys. See you next time.